Well, hello there. Here we go for your test. Couple housekeeping things I want to remind you of. Do not try to show your work on this front. There's just not enough room. It's too hard to grade. Not to mention, when I look at you guys' homework, you'll make silly mistakes because you're trying to squeeze it into an itty bitty little spot on that paper, and then you make a careless mistake. Use the back, okay? For example, the back of the paper, it's like this, blank. So make sure you number things nice and clearly. 1, 2, 3, 4, so on and so forth. Circle your answers. That would be great. So here we go. Let me explain numbers 1, 2, and 3. You need to decide whether the given number is a solution for the inequality. So, -7, 9, and 5. You're going to plug in where you see an x. Okay? And work it out if there's anything to work out, and ask yourself, is this greater or equal to -5? You work it out. Is it less than or equal to 12? And this is a compound inequality. So you take -5 times the number, and is it greater or equal to -10? Is it less than or equal to 30? You just simply answer yes or no, but you need to show your work by plugging it in and showing us how you came to a yes or no answer. No work, no points. And it's easy points if you just show some work. 4, 5, and 6. Okay? We're going to solve these inequalities and graph them. So, for example, if I were to do number 5 over here for you, 3x is less than -15, just like we worked on in a review in class. Dividing by 3, x is less than -5. Now I graph it. There's -5. This would be an open dot. It's less. Less is left. It's going to go like that. Okay? So that is how you're going to work 4, 5, or 4, 6, and 8. We're going to do 10 and 11. You want to graph these on a coordinate plane. They need to be in slope-intercept form, y equals mx plus b, which, lucky for you, they already are. All right, just please remember that that's a -1 or -1 over 1 in front of that x. And on your graph paper, you want to go down here and remember, graph the b, then the m, and then you got to shade. Remember, greater than, it's going to push you up. If it's making you less than, it is going down. Okay? So that's what you're doing on 10 and 11. 13, 14, 15. These are really pretty easy. So they want to know, is the 0.44 a solution to this system? Now, system is like these guys here. When we have more than one inequality or equation, and you graph them. So like here is the shaded in area. All right, and I'll even have a little fun with you here with the highlighter. So in this area here and this area here, if the 0.44 is inside this highlighted area, then it's a solution. If it's not inside these areas, then it's not a solution. Okay? So again, yes or no. And again, I would actually plot the 0.44 on this little graph, that you have right here in front of you on 13, 14, 15. 16 and 17. We're going to graph these systems. So on your graph paper, you're going to graph two lines. Remember, if it's a dashed line or a solid line, all right. So again, let me review with you that I guess we can go with that color. Greater than or equal to, that's going to be, I'm sorry, that's totally off. What am I doing? greater than or less than, that's going to be a dashed line. If it's greater than or equal, or less than or equal, that's a solid line. Okay? And just remember, when you graph, you should take your lines and just make them go kind of straight up or straight down from the line. Make them perpendicular. That helps you to figure out where do they overlap. Now in 16 and 17, you got to make sure they're in slope-intercept form, or these are vertical and horizontal lines. It's crossing the x-axis at 3. This one's crossing the y at -2. All right. This one, we need to put in slope-intercept. This one's all set. It just doesn't have a b. So put +0. This one, we got to subtract the x over. And then you have, I'm going to write this over here, -y equals -1x plus 5. Then divide by -1. Now, when we divide by a negative, forgot my sign there, we're going to flip that sign around, remember? And so now we have a +1x minus 5. So there's your line. So graph this one and this one, and make sure you shade and find out where they overlap. Okay, 19 and 20. Solve the absolute value. You got to make your two problems, okay? Just like we worked on in class. Again, make the first one look just like this. The second one, change his sign. All right, and solve for x. You should have two answers. We're skipping 22, 3, and 4. Jumping down to 25 and 26. You're to solve these inequalities, just like you did up here. Make two problems, but remember the second one, you got to flip this guy around and change his sign. All right. So keep the x divided by 2, or plus 1. On the first one is greater than 8. The second one, flip it around and change his sign. And then graph your solution. This you just graph on a number line. Okay, remember, if it's an and, okay, like if it's a less than or greater than, this is an and problem. And the graph should be come in the middle like that. If it's an or, like greater or equal to, again, your graph is going to be like oars on a boat. It's going to go out. All right. And don't forget about your dots, solid or closed dots or open dots. All right. You're just doing number 28 in this section. You got to plug in -5 and -7 each separately and solve. Okay? And determine, and then just, solve it. Find the absolute value of the number, subtract 4. But you're going to have two answers. And finally, you're going to graph this function. So you want to make a table of values. Okay, so if I was doing number 33 over here, I would just pick like 3 and -3. And I would plug it in right here. So the absolute value of 3, all right, and then multiply it by 2/5. The absolute value of -3, and multiply it by 2/5. What do you get for your y? Okay, and plot those points and graph them on your coordinate plane. Okay, so make sure you show your work on the back. Make sure it's neat so Mr. Paxton and I can easily see it and grade it. If you have questions, make sure you ask. Take your time. All right. Have a great day. God bless.